Hello friends, again welcome in the next lecture of multivariable calculus. So in the last lecture we discussed definition of function, then domain of the function and range of the function, and we solved some example on the finding range and domain of the function. So there is a one more way of visualizing the behavior of function is its graph. So in the today's session we discuss the graph of the function. So our topic is graph. So first we write the definition. If f is a function, if f is a function of two variable, in a domain D, then the graph of the function f is a set of all points x, y, z in R cube such that z is equal to f of xy and xy is in domain D. So what is definition? F is a function of two variable in a domain D, then graph is the set. So we can write it is in another way, that is graph of f of xy. It is a set of all ordered triplets or x, y, z point in R cube such that z is equal to f of xy and xy is in domain D. So this is the graph of the function f. So earlier we also discussed the graph of the function of one variable, and that time we see graph of the function of one variable is a curve. It is a curve. So what we seen, graph of one variable function is a curve with equation y is equal to f of x. Similarly, the graph of two variable function is a surface. It is a surface S with equation z is equal to f of xy. And also what we can write, graph of two variable function S lies above x above xy plane or below xy plane. Okay, so graph of one variable is curve, or graph of one variable function is curve, and graph of two variable function is surface. Okay, this is our x axis, this is y axis, this is z axis. Suppose it is our domain. Okay, this is our domain D, and then what we write here, this is our domain D, then what we have written here, the graph of the function of two variable is a surface that lies above or below the xy plane. That is, this is xy plane, suppose this is above or below the xy plane. We can say this surface lies, suppose this surface is lies like this. Okay, suppose this surface is here. Okay, so suppose this is the surface S, and suppose here we take any point xy 0, because here xy plane z coordinate is 0, and then its image, how we write this image of this xy, f of xy, we can write this like this point, and this is nothing but our z is equal to f of xy. That is, z is equal to f of xy is just the height of the surface that lies from the xy plane, or below or above the xy plane. Is it? No problem. So suppose this is xy plane, then this surface lies above or below the xy plane. Okay, so what is graph? Graph is the collection or is the set of all points x, y, z, and this graph lies above or below. So getting this? So we will try to solve some example on this. So our first example we have to take, that is, sketch the graph of the function. So we will take first example. Sketch the graph of the function f of xy is equal to 6 minus 3x minus 2y. Okay, so we have to solve the first example, that is graph of the function 6 minus 3x minus 2y. So we have to sketch the graph. So what is solution? So the graph equation is z is equal to f of xy, that is, we can write z is equal to 6 minus 3x minus 2y, or it can be written like this, 3x plus 2y plus z is equal to 6. So what it represent? It represent, if it is there is two variable, then this represent a line, is it? But here how much variables? 3 variable. So it represent a plane. Okay, so which represent a plane, So for drawing graph, so what we have to do now? We have to draw the graph of this function. For this, what we have to find? We have to find the intercepts, x-intercept, y-intercept and z-intercepts. So for drawing graph, we find the intercepts. Okay, so for x-intercept, put x intercept is on x axis, there will be y0 and z0. So what should be this? 3 into x plus 2 into 0 plus 0 is equal to 6. So what we are getting? 3x is equal to 6, and this implies x is equal to 6 upon 3, it is 2. So our first x intercept is our 2. Similarly for y intercept, put x is equal to 0 and z is equal to 0. So what we are getting? 3 into 0 plus 2y plus 0 is equal to 6. And what it implies? 2y is equal to 6, and this implies that y is equal to 6 upon 2. It should be 3. So y intercept is 3. Okay. Similarly, what we can find? Put for z intercept. For z intercept, put x is equal to 0, y is equal to 0. So what we are getting? 3 into 0 plus 2 into 0 plus z is equal to 6, and therefore we are getting z intercept is 6. Therefore what we can write? Thus the points of intersection of plane to x, y, z axis are, so what we can write? Point 2, 0, 0, then 0, 3, 0, and then what we can write? 0, 0, 6 respectively. Okay, so plane intersect x axis at this point, y intercept at this point, y at y axis this, and here this is the z axis. So we will try to draw the plane or the graph. So this is, suppose this is x, y and z. Here is our 2, 0, 0. Here is our 3, 0, 0, and here is our, suppose, 0, 0, 6. So joining this, we are getting our required graph of the plane. This is the plane. Okay, in the first octant, as it is in two. So you know this in the two x and y plane, there is first quadrant, second quadrant, third quadrant. Similarly here is also first, second, third, fourth. So it is, this plane lies in the first octant. Okay, so the graph of plane lies in the first octant. Why it is octant? Because there is a 8 parts. Okay, so are you getting this? So we can sketch the graph of the function of 2 variable. Similarly, we can take one more example. Similar question is there. Sketch the graph of the function So we will go for next example. Sketch the graph of the function f of xy is equal to square root of 9 minus x square minus y square. Solution. So in the first lecture we solve, or we find the domain and range of this function. If you remember this, Try to remember. Now what we have to find? The graph equation is what? Z is equal to f of xy. That is what we can write. Z is equal to square root of 9 minus x square minus y square. If you squaring both sides, what we are getting? Z square is equal to 9 minus x square minus y square. Try to simplify. Therefore, x square plus y square plus z square, it is equal to 9. So what it represent? Can you think? Try to remember this. What is it? Which represent a equation which represent a sphere with center is what? With center 0 0 and radius is 3. Okay. So this is the standard equation of this sphere. Okay, x square plus y square plus z square is equal to r square. It is a standard equation. That is equation of a sphere with center 0 0 and radius is r. Here r is equal to 3. But if you take the square root of this, what we are getting? Square root of this x square plus y square plus z square is equal to 9. And if you take solve it, is z square is equal to 9 minus x square minus y square. That is the reverse step. So what we are getting, if you take square root, then it should be what? Plus minus 9 minus x square minus y square. How much values we are getting here? 2 values, that is positive and negative. What it means? This is a whole sphere, but this equation is not a whole sphere. This for positive z, that is z is equal to 9 minus x square minus y square. It represent, or here z is positive, therefore it is the upper hemisphere. It is a upper hemisphere, and if it is negative, then it represent what it represent? It represent a lower hemisphere. What it represent? It represent a lower hemisphere. But what is here? What is here? But z is greater than or equal to 0. What it implies? That the graph of z is equal to square root of 9 minus x square minus y square is upper half. Or upper half or upper hemisphere. Sphere of upper hemisphere of this sphere x square plus y square plus z square is equal to 9. So what it means? This graph of this function is a upper hemisphere. You can draw this. This is, try to draw this. This is x. It is x, y, and z. Then you can draw this. This is the upper hemisphere. Okay. So you can try to draw this is our sphere. So graph of this function, this is nothing but z is equal to square root of 9 minus x square minus y square. Okay. So upper hemisphere of the sphere x square plus y square plus z square. What this shows? That is, there is not a equation in x, y, x and y, which represent whole sphere. That is, there is not a equation like z is equal to f of x in xy, f of xy in xy, which represent a whole sphere. So we cannot find, or we are not able to find the equation like this which represent a whole sphere. Okay, getting this? So this is the second example. Similarly, we can solve so many examples on the graph. So we will take one more example. So we draw one more graph, or we take one more example. Find domain, range and sketch the graph of the function h of xy is equal to 4x square plus y square. Solution. So what we have to find here? We have to find all these three things, that is domain, range, and also we have to sketch the graph. Okay. So what is domain? Domain is the set of all points where the function is defined. What is range? Range is the set of all images. What is graph? It is again a set of all points x, y, z in x, y, z in R cube. Okay. So we will find one by one. So first domain we have to find. So what is given? H of xy is equal to 4x square plus y square. So think about this function. For finding domain, what we are keeping in mind? Where this function is not defined. Okay. So where it is not defined, here is a square root, no square root, so no problem. Here is a denominator, no, never denominator will 0. Then what about, there is not a logarithmic function, there is not other function, it is simply a algebraic function. So what we can say that for any value of xy, we can find, or we are able to find the h of xy. So what we can find, it is possible to find h for all ordered pair xy in R square. Therefore our domain of R square is, domain of function is whole R square, or we can say that R2 or xy plane, So what we can write, the function h of xy is defined for all xy in R square, hence domain of h of xy is R square. So our first target is over. What is next? Next is what? Range. So for range, what we can write? Range of h of xy is equal to all z. Try to remember all z. Z is equal to h of xy and all xy is in domain. Okay. So what is our z here? Z is equal to what is h of xy? 4x square plus y square and all xy is in R2. Okay, domain of the function. So what we can say that we have x square, value of x square is always positive or non-negative, and value of y square is always non-negative. What we can say that 4x square plus y square, it is always what? It is always non-negative, and this implies we can say that all h of xy is always non-negative. So how we write the set? Range of h of xy, it is equal to what we can write? It is the set of all z, where z is here. What we can write? That is our z is greater than or equal to 0. Okay, all z where z is greater than or equal to 0 and all xy belongs to R2. Okay, so what we can write? This is nothing but our interval 0 to infinity. Okay, so our range is close 0 to infinity. Interval is 0 to infinity. Okay, so second target is over, and what we have to find next? We have to sketch the graph of the function. So how we sketch the graph? For the graph equation is h of xy is graph equation of h of xy. We will the graph equation is z is equal to h of xy. That is what we can write? Z is equal to 4x square plus y square. What it represent? Y is equal to x square, x is equal to y square. What it represent? It is in two dimension. What it represent? This represent the parabolas. Okay, symmetric about x and symmetric about y, we can say. And what this represent? Here is a z is equal to 4x square plus y square. This represent which is a paraboloid. So how we draw or sketch the graph? So this is symmetric about what? Symmetric about the z-axis. So this is our paraboloid. Okay, so this is our z is equal to 4x square plus y square. This is our x, y and z axis. Now try to think. If you cut this, it is into the horizontal. We cut this. So what we can say that horizontal trace, what it represent? If you take the horizontal traces of this paraboloid, then we are getting ellipse. we are getting the ellipse. And if you take the vertical trace, then what we are getting? Vertical, that is we cut this like this into the vertical traces, then we are getting what we are getting? We are getting a parabola. That means if you cut horizontally to the paraboloid, then we are getting the ellipse, and if you cut vertically to the paraboloid, we are getting the parabolas. So what we did here, we find range, we find domain, and we draw the graph of the function, and graph of this function is nothing but a paraboloid. Okay, so similarly we can solve so many examples on the domain range graph. So you can solve, it is for homework. So if you remember, in the previous lecture we was discuss one very important function, that is Cobbs-Douglas production function. Cobbs-Douglas production function. The graph of the Cobbs-Douglas production function is also can be determined by using the specific value of B and alpha. What is Cobbs-Douglas production function? P of Lk, it is equal to what? B L raised to alpha k raised to 1 minus alpha. Take specific value for B and take specific value for alpha and draw this graph by using maxima. So you can draw this graph also. So graph of the Cobbs-Douglas function also we can determine. So in the today's session what we see, we discuss the graph of the function that represent behavior of a function. So this is the one more view. So thank you very much.